Welcome to E-Pathsala Architecture lecture series for M-Arch students. And in this module, we are going to discuss on solar photovoltaic systems, and it is called solar PV systems. And the learning objectives are current scenario, basics of photovoltaics, PV technologies, components of PV system design and applications. Energy scenario of world and India. India with its large population and rapid growing economy needs access to clean, cheap and reliable source of energy. India is endowed with a huge solar energy potential, with most of the country having about 300 days of sunshine per year and annual mean daily global radiation in the range of 4 to 6 units per meter square in a day. And India is located, and fortunately we have 300 sunny days in a year, and the average solar radiation will be in the order of 4 to 6 kilowatt hour per meter square in a day. And this is about the current energy scenario in the country till October 2016. This is total installed capacity. At the time of independence, around 1950, we had only 1300 megawatt of electricity installation, just 1300 megawatt. But currently we have reached 3,06,358 megawatt, over 300,000, 3 lakh megawatt capacity. So, and this is majority is from thermal based power plants, and total thermal it is about 2,13,229 megawatt, which is about 69.6 percentage, and the total thermal is combination of coal, gas and oil based power plants. From coal, that is 1,87,253 megawatt, which is about 61.12 percentage, and gas based power plants, that is about 25,057 megawatt, which is about 8.18 percentage, and oil based power plants 919 megawatt, which is about 0.3 percentage. Coal based, gas based and oil based coming under total thermal based power plants, and the contribution of total energy scenario, which is about 69.6 percentage. And hydro, again it is renewable, and major hydel power plants through which we can generate, we have installed 43,112 megawatt, which is about 14.1 percentage, and nuclear 5,780 megawatt, which is about 1.9 percentage. Renewable energy systems, and from Ministry of New and Renewable Energy the data is obtained, and we have installed through renewable energy systems about 44,239 to 237 megawatt, which is about 14.5% in the total Indian energy scenario, and which is remarkable, 14.5% from renewable in the total energy scenario, which is really remarkable. And we have separate ministry, that is Ministry of New and Renewable Energy, to promote renewable energy in the country, and no other country is having separate cabinet ministry to promote renewable energy. And out of 100%, 14.5% from renewables, which is about 44,000 plus megawatt of electricity. Overall, currently 3 lakh capacity of electric installed capacity we have installed in the country. And this is about grid interactive power capacities in megawatt. and from wind, and from solar, from small hydro, from bio, waste to. So, this is completely renewable energy based power plants, and wind is I mean it is a major resource among all renewable energy sources, and we have installed about 28,082.95 megawatt of electricity from wind energy, and which is remarkable. We keep 4th position in the world after China and USA and Germany. We keep 4th position in the world, and so we have very good potential and very good installed capacity, and 28,000 plus, which is really remarkable through wind alone, and followed by solar power. And solar power, we have installed about 8,500 plus, and which is really and going up like anything. And recently from 2010 onwards, and the installation was started, and within say 6 years we have reached 8,500 megawatt of installed capacity through the solar power. And small hydro, it is coming under renewables, 4,323.35 megawatt from small hydro power. From biopower, that is biomass direct combustion, gasification and bagasse cogeneration, and which is about 4,882.33 megawatt, and waste to power about 115.08 megawatt. Overall from renewables about 45,916.94 megawatt of electricity from renewables alone, and in this, and wind and solar, it is really picking up in the country. And this is about off grid power plant, that is biomass non bagasse cogeneration, that is about 651.91 megawatt, biomass gasifier in rural areas for the industrial applications is 18.15 megawatt, and aero generator, it is about 2.79, and solar photovoltaic systems 361.98, and windmills and micro hydel, it is 18.81, overall 1,382.68. This is off grid, that is decentralized power generation, and this is not connected to the grid, it is decentralized, and in remote areas, in rural areas, and these kind of renewable energy based power systems have been installed in the country. And this is about a family type biogas plant in millions, which is about 4.8 millions have been installed as biogas plants in the country. And this is about renewable energy potential in the country from biogas plant, which is about 12 million, and biomass based power, it is 17,000 megawatt, and efficient wood stoves, it is 120 million, and solar energy 5 into 10 to the power 15 kilowatt hour per year, small hydro 10,000 megawatt, wind energy and 1,04,000 megawatt, and energy from urban and industrial waste 1,700 megawatt, ocean thermal, it is about 50,000 megawatt, and sea wave power 20,000 megawatt, and tidal power 10,000 megawatt. So, the country, the India is having huge potentials from renewable energy sources, and solar is enormous, and followed by wind and ocean energy and biomass based power. And since we have huge potentials of renewable energy sources, renewable energy technologies have to be created and in large manner in the country. And this is about the power generation split up, and power generation in billion units, and from wind 33.03 billion units, and from solar it is 7.45 billion units, and from small hydro up to 25 megawatt capacity it is about 8.33 billion units, and biopower about 16.95 units. Overall, totally 65.76 billion units of electricity being generated and through renewable energy based systems. And this is about state-wise estimated solar power potential, and Rajasthan, where we have about 142.31 gigawatt potential, Jammu and Kashmir 111 gigawatt potential, Maharashtra 64.32 gigawatt potential, and Madhya Pradesh about 61.66 gigawatt potential, and Gujarat 35.7 and Tamil Nadu 17.67 gigawatt potential. Overall, totally we have about 748 gigawatt potential, and the dark brown represents where we have very good potential in Kashmir. And we may be thinking Kashmir will have all the time ice and very cold weather, but however there is radiation, and for solar photovoltaic system the heat energy is not required, the light energy is sufficient, and in Kashmir, and clear sky will be always there, and there won't be any dust particles or cloudy, and the direct radiation is coming directly to the earth, and the solar radiation is very intensive and very clear, and the potential is huge in terms of solar PV potential. And then followed by Rajasthan is having very good potential, and Madhya Pradesh and Maharashtra, these areas are having very high potentials of solar radiation, and followed by Gujarat and other parts of the country. And this is about the state wise estimated solar power potential, and here these are the various states in the country, and the solar potential is given in gigawatt, and these are the various states continued, and solar potentials are continued, and overall we have about 748.98 approximately 750 gigawatt potential we have through solar energy. Even 1% is tapped from these resources, and we can have and continuous power supply in the whole country. And this is about the ministry's detail, that is the Ministry of New and Renewable Energy, a nodal ministry of Government of India for all matters relating to new and renewable energy. Objective of the ministry is to develop and deploy new and renewable energy for supplementing the requirements of the country, and the target, that is the 5 times increase in the renewable energy capacity by the year 2022, 175 gigawatt. This is a huge target. By the year 2022, the MNRE, the Ministry of New and Renewable Energy, aiming to install 175 gigawatt power. And this is about GNNSM, that is Jawaharlal Nehru National Solar Mission. This is the mission roadmap, and grid connected solar power, and from 2010 and 13 1100 megawatt, we have surpassed this already. From 2013 to 17 and 4000 to 10,000 is expected. We are going to reach shortly 10,000 megawatt, and it can be achieved very easily. And by the year 22 and 20,000 megawatt is fixed, and it could be easily achieved. Off grid, and 2000 megawatt up to 2013 we already surpassed, and from 2013 to 17 1000 megawatt is expected. It can be achieved easily, and by the year 22 2000 megawatt is expected, which could be met easily. And solar thermal, like solar water heating systems and solar cooker and cooling purposes and industrial process heat applications, etc., and 3 million square meter collector is targeted, and from 13 to 17 15 million square meter collectors are targeted, and 20 million square meters is targeted for the year 2022. And So, now and so 50% of this and we are achieved already. And solar lighting system 5 million is targeted up to 13 and then 10 million up to 2013 and 17 and till 22 it is about 20 million and over 50% has been achieved already in the country. And that is about solar energy scenario in the country. So, we have seen the various potentials of renewable energy sources and solar energy potential and how much we have installed in the country from solar, from wind, from biomass and everything we have seen. And the solar energy potential in various states in the country, and we have seen 750 gigawatt potential we have, out of which 8,500 megawatt has been already installed in the country. And because of the solar energy mission, and so every year the installations are increasing, and by the year 2022 175,000 gigawatt should be from renewables, out of which 100 gigawatt should be from solar energy, right. With this background, and we are going to see the solar photovoltaic technologies, and before we see the technology, and it is good to discuss about the basics of photovoltaic system. Photovoltaic system, and it has a semiconductor device, and the solar PV is a semiconductor device which converts sunlight directly into electricity, from solar radiation into electricity. And a solar PV panel, when exposed to the sunlight, generates voltage and current as its output terminal. And the higher is the intensity of the sunlight, the more will be the electricity generated from it. And it does not have any moving components. It receives solar radiation and it converts directly into electricity without any moving components. Very simple system. This is about the semiconductor device, solar photovoltaic module. And so, this module has various layers and it is built in, and the top layer is glass cover, and next encapsulant, and the solar cells, and at the bottom again encapsulant, and at the bottom Tedla. And these are the various layers in the solar PV module. The body, the parts of PV cell, because of the photovoltaic cells and the silicon parts are fragile in nature, and manufacturers protect them in a body of clear plastic or glass. It has high transparency to the light wavelengths that produce the most electricity in the silicon. About the silicon, you will find two thin flat layers of silicon inside the cell. One layer is called P type. It has silicon mixed with the traces of boron. The other called N type mixes silicon with phosphorus or arsenic. The P and N type layers produce positive and negative electric charges. And the wires, the cell has a set of thin and flat conductors on top of the silicon. The manufacturer makes these as thin as possible to minimize the light they block. And the back conductor, the silicon has a large area flat metal conductor under it. Since light enters only from the top, the manufacturer can cover the entire bottom area with conducting material. And so, these are the components of solar PV cell. And here, that is the working principle, and this is the solar cell, and at the top the N type silicon, at the bottom P type silicon, and in between P N junction, and the junction attaches the P type silicon and N type silicon, and this is called P N junction. And here the sunlight strikes the solar cell, and this is the exploded view. And here when the photon strikes the solar panel, and here you find the electrons, the negative electrons are flowing, and here positive electrons are ejected, and actually this is the hole created, and the n type electrons are trying to fill up the p type holes, and here the load is connected, and you can have electricity. So, this is about solar PV cell working principle. It is just semiconductor device. When the sun rays strike the solar cell and the electrons are ejected, n type and p type, and when it is connected, and you get lighting load. And again it has various layers as we discussed, and maybe at the top you have the glass for the protection and transparent covers, and then here it is exploded view it is given, and here p n junction, that is n type junction and p type junction, it gets connected with the load, and you get the voltage and current, and the product of voltage and current, it is the power. And the solar cell is a small semiconductor device which has a light sensitive NP junction. When solar light rays strikes the NP junction, and the DC EMF is generated with P terminal as positive and N terminal as negative. And the nominal ratings of a typical solar PV cell with when exposed to the full sun light or voltage, which is about 0.45 volt DC current DC, and current 0.75 amp, that is DC, power, the multiplication of V and I, that is voltage and current, you get about 0.33 wattage. When exposed to the sunlight, the solar cell acts like a tiny DC cell. Several solar cells are connected in series parallel to get desired voltage, current, and the power. And this is about the photovoltaic effect. The photovoltaic effect is generated when photons hit in a semiconductor material with a high energy than the gap between its valence and conduction bands. And here you see the n type layers, and this is the junction, and the p type layers, and you find the holes in p type, and the n type electrons will try to fill the gap which is at the bottom, and so when the load can be connected, and you get electricity out of it. And the free electrons move on one side, that is the n side, while holes move on the other side, that is the p side. This is about the photovoltaic effect in the solar photovoltaic cell. And a difference of potential is created between n side and p side, allowing current through a load outside of the semiconductor. And this is the n layers and p layers and p n junction, and the holes are filled with the n type electrons, and the difference of potential is created here between the n side as well as the p side, and it allows current to flow, and this is the semiconductor device. And this is the equivalent circuit solar cell. It is a symbol of solar cell, and this is the solar cell circuit, and this is the photon current produced here, and this is about shunt resistance, and this is about the series resistance, and this is the negative and positive, and the load we are getting from here. And this is about the electrical characteristics of a PV cell. The amount of power available from a PV device is determined by the type and area of the material, the intensity of the solar light, the wavelength of the solar light. And here in this picture, and this is the graph between the voltage and the current. The power is multiplication of voltage and current, V and I. And here here we have the various suns effect, and this is about 0.25 sun, and this is about 0.5 sun, and this is the 1 sun, and this is the 2 sun. You may be wondering how 2 sun could be created here. So, when we concentrate the solar rays and we can increase the sun's effect from 1 sun to 2 sun, even the 5 sun or 10 sun, 30 sun, even up to 100 sun, and we can create by focusing the sun's radiation. And here the current and voltage output of a single solar cell under varying light levels, and 0.25 suns, and here and the current is lower. When the sun's effect is increased to 0.5, the current increases step by step. This is about the 1 sun, and this is about 2 sun. So, and when the sun's effect is increasing, the current is also increasing. And this is about the electrical characteristics of the PV cell. The sun rays, the radiation is, the photons are striking the solar PV panel, and this may be, and the solar radiation may be 1000 watt per meter square, and maybe the atmospheric temperature is maybe 25 degree Celsius, and here, and so, and when the photons are striking the solar cell, and there we have a N type and P type junction, and so when the loads are connected here, and here you find the voltage and current, and this is the variable resistance, and the electricity is generated through the PV cell. And this is about electrical characteristics of a PV cell, and this is irradiation, and this is the dark, and when there is no sun, this is the dark level, and this is when the sun is there, this is the irradiation, and this is the graph between the voltage and current, and this is open circuit voltage, and this is short circuit current, and when the voltage is maximum, when the current is maximum, that is when V max and I max, and there you get P max. So, when the voltage is maximum, when the current is maximum, then you get maximum power, and this yellow shade, it represents and the fill factor. Okay, that is the fill factor, that would be maximum when V is maximum and I is maximum, where you get maximum power, that is VI characteristics. And this is the fill factor. The fill factor is defined as the ratio of the actual maximum obtainable power to the product of open circuit voltage and short circuit current. It evaluates the performance of the solar cell. Fill factor I max into V max divided by I suffix SC and V suffix OC, that is open circuit voltage and short circuit current, and the maximum voltage and maximum current, and this ratio will give you the fill factor. Maximum conversion efficiency, that is I max V max divided by I suffix T and A suffix C. I suffix T, that is nothing but incident solar flux, and A suffix C, that is area of the cell, and this is about the fill factor. And this is about the PV cells and modules and arrays, and this is the one cell. When the cells are connected together, it becomes module. When the modules are connected together, it becomes array. When the arrays are connected together, it becomes solar PV power plant. The cells are the building block of PV systems, typically generate 1.3 to 3 watt of power, and modules, the panels are made up of multiple cells. So, PV cells are connected and you get module, and when modules are connected you get array. When you connect the arrays, it becomes solar PV power plant. So, and arrays are made up of multiple modules, and still need lots of other components to make this work, and typical system cost about ₹20 per watt. So, initially it was about 200 rupees per watt about 10 years back, and a few years back it was about 100 rupees per watt, and last year it was about 50 rupees per watt, and currently it has become 20 rupees per watt. Drastically the price is getting reduced about solar PV cell. And types of solar cells, and we have first generation solar cells and second generation solar cells. And in the first generation solar cell we have single and monocrystalline solar cells and multicrystalline solar cell. And in the second generation solar cells we have say ASI, that is amorphous silicon thin film solar cell, and CDTE, that is cadmium telluride solar cell, and CIS, that is copper indium gallium, and CIGS copper indium gallium selenide solar cells. This is about first generation solar cell and second generation solar cell. And this is about the third generation solar cell, that is nanocrystal based solar cells and polymer based solar cells and dye sensitized solar cell and concentrated solar cell. And these are the various types of solar cell. So, in this lecture we have seen about solar photovoltaic effect, the principle, and various types of solar cells. And thank you for the listening.